Venn diagrams, we're looking at P1, day one. That's foreign to me. In a class of 30 students, so our sample size here, our universal set's 30, 19 are studying French, 12 are studying Spanish, and 7 are studying both French and Spanish. Show the sample space below. Well, we're going to draw a rectangle for the sample space. We're going to have a circle for students taking French, a circle for students studying Spanish. We're assuming there's some overlap, and it actually tells us that there is overlap. These are students in a class, so I'm going to label this rectangle class. And for this problem, it doesn't tell us how many aren't doing either, but it does tell us 7 are studying both French and Spanish. So we can put that 7 right here. And that makes this pretty simple. 19 are studying French. So in this circle, there's got to be 19. We've already used 7 of those people. So that must mean there's 12 left. 12 plus 7 is 19. In the Spanish circle, there should be 12 total. We've used 7 of those. It means there are 5 people that take Spanish only. So if we add these numbers, 12 and 5 is 17, and another 7 is 24, but there are 30 students total. That must mean there are 6 students that are not taking a foreign language. Let's just add up the numbers, excuse me, to make sure this all works out. We are saying there are 12 that are in, excuse me, French, but not in Spanish. There are 5 that are in Spanish, but not French, and there are 7 taking both. We're saying that there are 6 people that are in this class, whatever class we're in, but they are not taking a foreign language. If you add those together, 12 and 7 and 5 and 6, we get 30, so it works out. Question that goes with this, P1. Keep in mind P3 is not till the 3rd day, so we're not going to do that. If you choose a student at random, what is the probability that the student is not taking a foreign language? So let me introduce you to a new notation. Probability that they're not taking a foreign language, that would be not French. This is the complement of the set. So if F means they're taking French, the complement of French means they're not taking French. And also not taking Spanish. So this would be the complement of Spanish. So if S means Spanish, this means not taking Spanish. So once again, this means not French and not Spanish. But we can use this symbol here for the complement if we want to make this more compact. So how many students aren't taking either? There are 6. How many students are there total? There are 30. So the probability is 1 out of 5, 20%, 20 out of 100. 0.2, you can say it in lots of ways. Let's go on to concussed boogers. On a football field of 22 players, so we got 22 players in total. 10 of the players have had a concussion, 15 of the players have picked their nose in public, and 8 have had both a concussion and pick their nose in public. Well, let's draw a rectangle for the sample space. Let's draw a circle for the students that have had a concussion, a circle for the pickers out there, and this is referring to football players, so that's this everything inside the rectangle. Now it says 8 have had a concussion and picked their nose. So that goes in this location, which is the intersection, which means that they've experienced both things. 10 players have had a concussion. So in the circle, there should be a total of 10 numbers. We have 8 here. That must mean that there's 2 left over in this space. This 2 represents the number of players that have had a concussion but have not picked their nose in public. Of the pickers, there's supposed to be 15 pickers. We have 8 of them accounted for, so there's 7 left here. If we add these numbers together, 2 and 8 and 7, we get 17. There are 22 players total. We are missing 5 players. If we add these numbers together, we should get 22, and we do. And once again, this represents people that had a concussion that have not picked their nose, people that picked their nose that have not had a concussion, people that have picked their nose and have a concussion, and these people have neither picked their nose nor had a concussion. If you choose a player at random, what's the probability that the player has had a concussion only? Probability of a concussion only. There are only 2 players that have only had a concussion. How many players are there total? There are 22 players. You could leave it like that, or you could simplify it to be 1 out of 11. That's the probability. The rest of the questions here are for the 3rd lesson. If we go to the back page, there's a couple more questions. You're having a pool party. That sounds lovely this time of year. There are with 20 of your closest neighbors. As you host, you serve watermelon and popsicles. That popsicles doesn't look like it's spelled right. Don't know if it is, but that looks whack. 9 of your friends eat watermelon, 11 of your friends eat a popsicle, and 5 ate nothing. Let's show this sample space. So we will call this neighbors. Could also call it pool party. We have some folks that had some watermelon, W. Some folks that had a popsicle, which I think is spelled wrong, P. And then we have people that ate nothing. So the ate nothing is where we're going to start with this, because we don't know what the overlap is like we did for the past problems. 5 ate nothing, that means they are neighbors, but they didn't have popsicle or watermelon. So we have 20 people total. We've used 5 of them. There are 15 people total that have to fit into these circles. 15 total. Of the people that are in the watermelon, there has to be 9 that fit in here. I'm going to end up erasing this. 9 in this circle. So of the 15 that we have left, 9 are in here. That must mean there are 6 people that are not in this circle, because 9 plus 6 is 15. Similarly, in this circle, there are 11 that had popsicles. So if we've used 6, it must mean there's 5 left here, because 5 and 6 is 11. And then if you go back here to the watermelon, this is supposed to total 9. We've used 5 of the people. There must be 4 left. See if these numbers add up. This is 9, 15, 20. There are 20 people. 9 had watermelon. That checks out. 11 had popsicles. That checks out. 5 had nothing. Totals to 20. So it works. A follow-up question. If you choose a friend at random, what's the chance that the friend ate both watermelon and a popsicle? So the probability that they had a watermelon and a popsicle, and once again, and is a symbol that looks like this, that stands for intersection, not a sad face. You take the total people that had both, which is 5, divided by that would be this intersection here, divided by all the people in this set, which is 20. If you want to reduce it, you can, but you don't have to. It's 25%, 1/4. All right, gamification. There are 100 students in the sophomore class. So let's start this out here. So this is going to be sophomores. Of the students, 25 own an Xbox. I have a circle for Xbox. 50 own a Switch. Circle here for a Nintendo Switch. And 40 don't own either. So the 40 is the easy part for this because it goes in neither circle. So there's 100 students total. We've just used 40. There are 60 left. In the Switch circle, we got to fit 60 people. I apologize. In the Xbox and Switch, we got to fit 60 people. But in the Switch box, we got to fit 50 of the 60. That means here, Xbox only is the difference between 50 and 60, which is 10. 25 on an Xbox, we got 10 here. So that means in this circle, we got to have the difference between 25 and 10, which is 15. If there are 15 in here and this whole circle has to be 50, that means this has to be 35. These numbers should have to be 100. If they don't, we've made a mistake. 10, well, let's add this way. 35 and 15 is 50, plus 10 is 60, plus 40 is 100. We have 25 in the Xbox circle. We have 50 in the Switch circle. So we are in good shape. If you choose a student at random, what's the chances that they own only a Switch? So the probability that they have a Switch only. So how many people own a Switch only? That's the favorable outcomes, 35. How many folks are there total in the sophomore class? 100. So it's 35 out of 100. You could reduce it. There's really no point. This also could be said that it's a 35% chance. If you choose a student at random, you'll choose someone that has a Nintendo Switch. The rest of these questions down here for day 3. Pets are us. In a park of 85 people, so that's our total sample size here is 85. And I'm just going to call this rectangle people. Got 85, it's going to fit in here. 55 are walking a dog. 25 are walking a paradoxosaur, and 20 are not walking any animal at all. So we have a circle for the dog walkers. We got a circle for the paradoxosaur. Now remember what a paradoxosaur is. A paradoxosaur, if you believe it exists, it doesn't. But if you don't believe it exists, it does. So we know that 20 are not walking any at all. So we can put that out here. And then we could say, well, there are 85 total. We've just used 20. There's 65 people left. Of those 65 that are left, 55 are in this dog walking category. 65 minus 55 is 10. That means what has to go here has to be 10. There are 25 people walking a paradoxosaur. We've just accounted for 10 of those. So there's 15 left in this intersection. There's 55 dog walkers. We've used 15 of them here. So there's 40 left here. So once again, 40 people are walking dogs, but not a paradoxosaur. 15 are walking both. 10 walk a paradoxosaur, but not a dog. And 20 walk nothing. 40 and 15 is 55, 65, 75, 85. We've got all the people. If you choose a person at random, what's the probability that the person is walking both a dog and a paradoxosaur? Probability, they're walking a dog and intersection paradoxosaur. There are 15 of those people. There are 85 people total. If you want to reduce this, by all means. If you don't want to, that's cool too. Let's see. Binary art. There are 10 types of people in this world, those who understand binary and those who don't. If you don't get the joke, it's because you don't. Of the 50 people in study hall, 22 of them are taking a computer course. 30 of them are taking an art class. 15 are taking both computer and art. So we are looking at people in study hall. You could also say that's people. That would be full. That would be cool. There are people taking computer, people taking art, and people taking both. So it says the people that are taking both, there are 15. So that's going to go in the intersection. And then of the art students, there's supposed to be 30 art students. We've used 15 in the intersection. So there's 15 that are taking art but not computer. There are 22 people taking computer courses. We've used 15 of them here, so there are 7 left. If this adds up to 50 people, we're done. 15 and 15 is 30, plus 7 is 37. We are missing 13 people, so there must be 13 people in study hall that are not taking art or computer. If you choose a student at random, what's the chance that the student only takes computer. So we're doing computer only. Well, there are 7 students that take computer only. There are 50 students total, so it's 7 out of 50. Alrighty, that finishes it up.